Hello, everyone. I'd like to thank you for taking the time to attend today. My name is Lance Zurich, and I am the product manager for the Fischertechnik division over here at Studica. And today I'm going to give you a brief overview of the Fischertechnik STEM Prep 2.0 and STEM engineering sets. Now, these sets were designed to enable educators to provide students with a project-based standards-focused curriculum program which involves inquiry, design, and problem solving. And the curriculum for each of these sets was created especially for Fischertechnik and Studica by noted educator and STEM expert Tom White. So, on that note, let's get started here. So the big question, what is STEM education? Well, of course, most educators are probably well aware that the term STEM is an acronym, the letters of which stand for science, technology, engineering, and mathematics. Now, if you're involved in any aspect of education, you probably can't open your email box without seeing the word STEM highlighted in the subject line of at least one of your daily messages. And you certainly can't read an educational journal or visit an educational conference without being bombarded by references to STEM. And the reason for this is really quite simple. To quote the bipartisan Congressional STEM Education Caucus in their report on the importance of STEM education, STEM education is necessary because it helps to provide the scientists and engineers needed for future development, provides the future workforce with the skills required of a high-tech world, and it builds the foundation for scientifically literate voters and citizens. Now, as such, STEM education could really be considered a matter of national security. On every level, the world around us is changing at a frantic pace. STEM education, it could be argued, enables us both as individuals and as a nation to understand and keep up with these rapid changes in technology, changes which in turn are altering the demands and the scope of industry. And obviously, if we as a nation are to keep our stature and position on the world stage, this requires us to keep pace with the rapid developments that are occurring all around the globe, where countries such as China, India, and many others are making major investments in state-of-the-art infrastructure. And while all of this is well and good, and while we should of course all strive to be good citizens, many students might instead ask, so what's in it for me? Why do I want to study engineering or coding or whatever it might be? So let's consider what it means on the individual level. Well, first off, a few years back, the United States Department of Commerce released a set of projections for the decade leading up to 2018. Now, these projections indicated that STEM occupations should grow by 17% compared with just 9.8% growth for all other occupations. Now, in March of 2017, the Office of the Chief Economist released a STEM Jobs 2017 update, which essentially looked at how these numbers were playing out up until the year 2015, the end of the year 2015, with 3 years still left in the initial projection. And what they found at that time was that while the projected STEM growth up to that point, once again, the end of 2015, was as expected up significantly, albeit still a little bit less than they expected to reach, of course, by the end of 2018. So by this, I mean that they had reached 14% growth instead of the whole 17%, which was still to come. What they found at that time, though, was that the actual growth for non-STEM jobs, which again was expected to eventually reach 9.8%, had reached instead only a fraction of that growth, 1.7%, a really stark difference. Now, here's the statistic I like to share that should give anyone entering the job market of the future pause. And this comes from J.D. Chesloff in his Education Week article from March of 2013. To quote Mr. Chesloff, across the country, across all occupations, there are 3.6 people for every one job. In STEM fields, there is one person for every 1.9 jobs. Employers can't find the talent to fill these jobs, which is even more surprising considering that the U.S. Census Bureau recently reported that the median salary for engineering majors was the highest of any profession, end quote. Now, as Chesloff goes on in his article to state, quote, supply is low and demand is high. There is a mismatch between projected future jobs requiring STEM skills and the projected supply of qualified workers to fill them, end quote. Now, going back to the STEM Jobs 2017 update released by the U.S. Department of Commerce, which I referenced a few slides ago, here are 3 key points mentioned in this report that are well worth keeping in mind when considering the importance of STEM education to the worker. Key point number 1 would be that, quote, STEM workers command higher wages, earning, on average, 29% more than their non-STEM counterparts in 2015, end quote. Key point 2 relates to the fact that many graduates with STEM skills may not always end up in what are strictly considered to be classic STEM jobs, things such as scientists and engineers. To quote the report again, STEM degree holders enjoy higher earnings regardless of whether they work in STEM or non-STEM occupations, end quote. Now, there was a video I saw recently on YouTube, and it was posted by the Women's Forum for the Economy and Society. And I kind of think that the title of this video really sums up things quite nicely. And that the title of the video was, quote, "Every company is a tech company." Now, what I take from that is essentially what students want to keep in mind is that whatever a company makes, whatever a company sells, whatever service it performs, at some point, STEM skills are required to help that company fulfill their mission. Going back to our key points, key point number 3 relates to job growth. Quote, "Employment in STEM occupations grew much faster than employment in non-STEM occupations over the last decade, 24.4% versus 4% respectively, and STEM occupations are projected to continue to grow by 8.9% from 2014 to 2024, compared to just 6.4% growth for non-STEM occupations," end quote. Now, of course, the trick for educators is to find methods for getting students involved with STEM, and in particular, the most highly in-demand technology-focused skill areas, things such as engineering and coding, and to get students involved in a way that engages their interest and creativity while at the same time developing their work habits, the way of approaching problems, and the skills that they will need to draw on as they move forward in their careers, both their academic careers and, of course, in their working lives. Now, most experts agree that one of the most effective methods for teaching STEM is by providing exercises where certain results will occur, and students have to discover why they occurred, or where students have to find a way to achieve a specific outcome. Well, how do they do this? Well, they can do this through experimentation, through research, and through trial and error activities. In short, what they do is they find the answers to these questions through the use of hands-on, project-based learning. And this brings us to the focus of today's webinar, which is, of course, as I said, the Fischertechnik STEM Prep 2.0 and STEM engineering sets. Now, both of these sets have been designed to provide a guided, project-based learning experience that comes complete with detailed, standards-focused curriculum, all built around the unique Fischertechnik building system. And that might beg the question, so what is Fischertechnik? Well, just to provide you with a little bit of background, Fischertechnik is a flexible and innovative construction system. Now, unlike other popular construction sets designed to simply stack, Fischertechnik was created with more of an engineering mindset. The core building block in the Fischertechnik system, like you see in the little graphic there, is unique in that it allows attachment from all 6 sides, and thus it allows for almost limitless design possibilities. Now, many of the parts are designed to slide together and lock in place, and the hundreds of different parts available will also help students to address very specific design needs. Fischertechnik was created back in 1964 by German inventor Arthur Fischer, noted for countless innovations that are used in the construction and the automotive industries. Mr. Fischer, at the time of his death in 2016, held more patents in his name than Thomas Alva Edison had accumulated during his lifetime. Now, besides Fischertechnik, Mr. Fischer was the inventor of synchronized flash photography, which was back in 1949, and he was also the creator of the expanding nylon wall plug, like you see him holding in the photo, which is used in conjunction with a screw or a bolt to help anchor a heavy object to a wall or other surface. Now, his company, the Fischer Group, employs thousands of individuals worldwide, producing many variations of fastening devices used in building construction, as well as various components that are used in the automotive industry. And they are also known for providing consulting services in regards to various manufacturing processes. Now, I'd also like to mention at this point that Fischertechnik was the very first construction set to offer students the ability to build and program their own robots, and that was using the original pre-Macintosh era Apple computers. Now, almost since its inception, Fischertechnik has been used by middle schools, by high schools, by colleges, and universities all around the globe to explore STEM-related subjects. And these, of course, would be things like robotics, renewable energy, mechanics, optics, physics, pneumatics, and much more. Fischertechnik has also been used by many companies, including companies like Porsche, Daimler Chrysler, and BMW, just to name a few, for industrial simulation and training purposes. Now, in addition to this, over the last few years, Fischertechnik's line of pre-assembled simulation models have found wide adoption for demonstrating and exploring the world of IoT, which is also known as the Internet of Things, where industrial processes can be monitored and controlled from the cloud. Now, as such, more than being just something that students are only going to use for a year or two in their development, Fischertechnik is really designed so that students can grow along with it. Essentially, as students progress through their academic careers, they can also progress through the levels of Fischertechnik education solutions which are available. The Fischertechnik STEM Prep 2.0 and STEM engineering sets are two of the most important members of the Fischertechnik education family. STEM Prep 2.0, which was newly revised just last year, is designed for exploring essential aspects of technology with a focus on physics, robotics, energy, and power. STEM engineering is designed to provide a comprehensive overview of robotics, coding, and automation systems. Each of these STEM focus sets is designed to provide all of the materials you will need, and by that we mean both the physical and the instructional materials, to enable teachers to offer a complete, daily STEM-focused classroom experience. STEM Prep 2.0 contains over 75 academic hours of curriculum material, and STEM engineering contains over 150 academic hours of curriculum material. So essentially, if you offer your students a STEM education class of a single 50-minute period each day for 5 days a week, this would provide you with enough curriculum material with the STEM Prep 2.0 set to essentially cover half a year, and with the STEM engineering set to cover a full academic year. The curriculum for each of these sets comes in a handy PDF format. There is a curriculum PDF for the teacher to conduct the class, and also a separate PDF that can be shared with students, which acts as a guide for the class activities, and it helps to keep everyone on the same page. And to assist new users of the Fischertechnik system, the curriculum also includes a helpful tutorial section. This section provides guidance on identifying the many types of parts that are included. It shows how these parts fit together, and it walks users step by step through the building of a simple model. The STEM Prep 2.0 and STEM engineering sets are also designed to be somewhat dual function. Now, besides being designed so that educators can conduct a curriculum-centered, project-based STEM class, they also include full-color step-by-step assembly manuals in PDF form from popular Fischertechnik education-focused sets. Now, these assembly manuals can, of course, be used as a reference when students are, of course, going to be asked to create their own original projects, as they will be asked to throughout the course of the curriculum. But they also allow you to build all of the models shown in each manual with the parts included inside of each set. In fact, the STEM engineering set allows you to build all of the models found in Fischertechnik's 3 most popular robotics-focused sets. And the STEM Prep 2.0 allows you to build all of the models found in 8 different STEM education sets, as well as the Robotics BT Beginner set. And we'll discuss this all a little bit later. Now, as I mentioned at the very beginning of the presentation, the curriculum material found in the Fischertechnik STEM Prep 2.0 and STEM engineering sets was created by a man named Tom White. Now, Tom is a noted educator, and he's been involved in STEM education since the 1970s, and he's known for designing programs for both educational institutions and for industry use. Now, in fact, as an expert in hardware and software integration, Tom was pivotal in introducing subjects such as CAD, CAM, control systems, digital control, additive manufacturing, and other like topics to the classroom. Now, currently, Tom is the Director of Technology for STEM curriculum at the globally recognized industrial manufacturing company, Siemens. Now, I'd like to point out that this is not the first time that Tom White has created curriculum around Fischertechnik. Now, besides also being the creator of the curriculum used in our elementary-focused Introduction to STEM series, and also our other project-based offering, the Robotic Competition Set, each of which are the subject of their own webinar presentations. If you'd like to attend those, you can, of course, look those up on our page. But anyway, Tom has incorporated Fischertechnik in many of the educational programs that he's designed over the years. And Tom has often said that he believes that Fischertechnik is the ideal construction set for any kind of engineering-based curriculum program, and he's given several reasons for this. Some of the reasons are that he likes that the materials can be used and reused. Things that are built can be taken apart and reassembled into something completely different. He likes the versatility of Fischertechnik and the fact that it offers so much more economy than, let's just say, purchasing an expensive piece of equipment. For example, something like a robotic arm that you might only use for a few experiments or projects and then put on a shelf to gather dust until the next semester's class. He also appreciates that the Fischertechnik system, with its wide assortment of very specific mechanical and structural parts and components, offers students almost limitless creative opportunities. Now, the curriculum for both the STEM Prep 2.0 and the STEM engineering sets has been designed to address some of the most widely recognized academic standards that are currently in place in the United States. This includes the College and Career Readiness Standards for Math, Science, Reading, and Writing, the NSES Content Standards, the Standards for Technological Literacy, ISTE Foundation Standards, and the Next Generation Science Standards. Now, when Tom White put together the curriculum for these two sets, he had several goals in mind. First, based upon his own observation that various types of teachers have different strong points. For example, he'll sometimes say that he sees his own strong point as being more in the creation of curriculum, such as we're looking at now, more so than conducting a lecture. Well, with this in mind, he focused on creating a curriculum that would provide a broad foundation of tools for all types of teachers to be successful in providing this class, so that they could instead focus on the needs of the students. Now, materials have been included at the beginning to familiarize new users with how the system works, as I mentioned before, and each section of the curriculum clearly spells out how things will be covered in that unit. Essentially, this was all designed to be a turnkey solution that would provide everything teachers are going to need to conduct the class in one place. In short, the curriculum was designed to provide a clear roadmap both for teachers and also for students, with the learning facilitated through the extensive use of projects and problems for the students to address. Now, the goal was also to enable teachers to provide students with engaging curriculum-based projects that had an authentic objective in solving real-world problems and which contain embedded academics. The detailed curriculum with each set, if followed, will allow educators to provide what is essentially a standalone project-based STEM education class. But of course, as I mentioned before, each set also includes step-by-step instructions for building the models found in various topic-focused Fischertechnik STEM sets. What the students experience? Well, under this project-focused model, students are told upfront what they will need to learn and what they're going to need to understand. They're given a real-world scenario where they have to take on the role of a professional working on a team, which has been presented with a design challenge that they must devise a solution to. And then they are also provided with different tools and pathways to help them achieve this goal. Now, among other things, students are going to be asked to perform research. And by that we mean research both inside and outside of class. And they have to learn the documentation process. And this means things like creating a design brief, maintaining a digital engineering journal, and so on. And students are also going to be required to collect data. They're going to learn firsthand how data acquisition works. They're going to learn how to process data, how to put the data into graphs and other formats, and so on. Students are given a technical literacy task driven by the project. Fulfilling this task will require them to gain the knowledge and the tools needed to address it through research and exploration. Students will perform a series of specially designed enabling activities through which they will acquire the necessary science, math, and tech-based skills to help them successfully address the project. They're going to need to devise solutions to their tasks and create prototypes, of course, using the advanced Fischertechnik modeling system. Now, where required, students will also create and install the programs needed to control these prototypes. They will document every step of the entire project, and at the end, they formally present their findings, including a demonstration of the prototype. Now, at this point, let's look at the sets themselves. And First off, we'll begin with the Fischertechnik STEM Prep 2.0, which you see on your screen now. Now, the prep in the name, like STEM, is an acronym, and in this case, it stands for Physics, Robotics, Energy, and Power, which are the subjects focused on in this set. Each set is designed to be used by a team of 2 students at a time. The set itself contains 2,260 parts and components, and this includes things like the ROBO Pro LT software, the Bluetooth smart controller, an electronic module, a pullback motor, a solar motor, an XS motor, a mini motor, a compressor, 2 solar modules, a gold cap energy storage unit, an NTC resistor, a phototransistor, an LED, 2 rainbow LEDs, and many other parts, all of which come packed in a sturdy Gratinal storage box. Now, the project themes addressed in the STEM Prep 2.0 set include the following: sketching and documentation, simple machines, mechanical systems, structures, conversion and storage of energy, electronics, optics, digital communication, and programming control systems. And once again, as I mentioned before, the curriculum for the STEM Prep 2.0 is designed to provide enough material to cover 75+ academic hours. The STEM Prep 2.0 set also includes step-by-step pictorial instructions culled from 9 different Fischertechnik sets. These include the drive system set, the eco energy, which basically focuses on renewable energy, the pneumatics, the mechanics, the physics 1 and physics 2 sets, the electronics, the optics and light, and the robotics BT beginner set. The one thing I will mention is that aside from 5 models shown in the instructions for the eco energy set, which incorporate the optional fuel cell add-on, which of course you can purchase separately from us if you so choose, all of the other 118 models shown in these instructions can be built with the parts found in this set. So as such, even if you didn't wish to use the curriculum for whatever reason, the STEM Prep 2.0 set would still be a very convenient and affordable way to have the building and learning options from these 9 Fischertechnik STEM sets in one box. Next, we're going to look at the Fischertechnik STEM engineering set. Now, this set can be used as a follow-up to STEM Prep 2.0, or it can be used entirely on its own. It is designed to provide students with a comprehensive overview of robotics, coding, and automation systems. Now, the set is designed for use by teams, once again, but in this case can be anywhere from teams of 2 to possibly even up to 4 students at a time. Now, the reason for this difference is because the projects in the STEM engineering set are going to be a little more elaborate than they are in the STEM prep set, and they also involve more steps than many of those that are found in the other curriculum. And because of this, it's easier to keep a higher number of students actively engaged in all the activities that are going to be needed to complete each of the projects. For example, the programming, the research, the building, and so on. Now, the set itself contains 890 parts components. This includes things like the ROBO Pro software. This is the full version of ROBO Pro. The robotics TXT controller, which has a full color touchscreen, Bluetooth, Wi-Fi capability, sounds, all sorts of other features. A Fischertechnik AccuSet, which includes a rechargeable battery pack and charging unit. You get 2 encoder motors, a compressor, 2 phototransistors, 2 XS motors, a mini motor, 6 push-button switches, a color sensor, an NTC resistor, 2 LEDs, 2 solenoid valves, a vacuum suction device, and once again, many other parts, all of which come packed in a sturdy Gratinal storage box. The project themes addressed in the curriculum for the STEM engineering set include the following areas: sketching and documentation, basic electricity, programming, sensing and vision systems, mobile robotics, actuators, fundamentals of automation and robotics, and once again, the curriculum here is designed to cover 150+ academic hours. Now, besides this, there are also activities included to address the following areas that come up during the course of the curriculum. There's a section on sketching, schematics, Ohm's law and power, an introduction to using the ROBO Pro software and to using the TXT controller, working with flow charts, open loop and closed loop programming, digital branching, edge triggered versus level triggered, logic gates, combinational logic, analog branching, variables, subprograms, data, sensors such as the digital switch and the digital phototransistor, analog sensors such as the NTC resistor and the color sensor, an introduction to the camera, a USB camera attachment that's included with the set, using the camera to detect motion, learning about color detection, creating a ball finder, which involves using the camera as a vision system on the robot, working with the line tool, the encoder motors, building the control panel, working with pneumatics, positions, recording positions, and utilizing existing programs and sub-programs. Now this set also includes the step-by-step assembly instructions found in the following 3 Fischertechnik robotics sets: the Robotics Advanced, the Robotics and Electro-Pneumatics, and the Robotics and Industry set. Now once again, if you wanted to work outside of the curriculum for whatever reason, this set will still contain all of the parts, the software, the controller, the power supply, etc., so that you can build any of the 22 models that are found in these 3 sets. And this includes things like color sorting machines, pinball machine simulations, mobile robots, robotic arms, and much more. Now at this point, as we've touched upon what's covered by each set, I think it's going to be most useful to show you exactly how the curriculum for the STEM Prep 2.0 and STEM Engineering sets is structured. Each unit of both the STEM Prep 2.0 and the STEM Engineering curriculum contains a roadmap of sorts where each of the following elements are addressed: the purpose, the concepts, the student deliverables, assessment and evaluation materials, an outline, standards, an authentic project scenario, a daily teaching plan, supporting activities, and resources. Well, just to put this into a little better context, we're going to take a look at the curriculum that accompanies the STEM Engineering set. Now again, while we will focus on material found only in this particular set, please note that the structure of the units and how subjects in both the STEM Prep 2.0 and STEM Engineering curriculum are addressed is essentially going to be the same for both sets. Now here you'll see the table of contents for the STEM Engineering set. The first thing I would like to note is that before we get into the specific units, and if you look closely, you're going to see that just on this one page that I have up right now, you'll see the listings for the units on sketching and documentation, and also the listing for the unit on basic electricity. But before we get into any of that, there is a section that will help any new users of the Fischertechnik system to quickly get up to speed. Now again, the core building blocks used in the Fischertechnik system are designed to attach from all 6 sides. And many of the other parts are designed for very specific purposes. So this is a little bit different than the simple stacking construction of many of the other building sets you may have seen out there. We've included this section right up front, both to increase your comfort with the system as a teacher and to also allow you and your students to get the most out of your building experience. First off, there's a section showing how the parts fit together and discussing the pin and groove assembly method that's used. There's a section showing you how to identify the different parts from the core blocks to more specialized pieces, things such as clip axles, girders, rivets, angle pieces, and much more. There's a section that shows you a picture of every part contained in each set, along with the name, the part number, and the quantity of that part that are included. Now, this can be especially useful if you ever wish to order additional quantities of any parts to add to your assortment, so it's good to use this. And for those educators who are also new to an approach such as this, there is a chapter that specifically discusses how to go about conducting a project-based STEM education class. Now on that note, let's jump ahead to a sample unit just so we can explore the structure that we discussed. Now this unit, as you will see from the image on the screen right now, is focused on programming. Now, the picture you see at the top of the page, the sample page shown here, is a graphic representation of the ROBO Pro programming software. Now, as you'll see in this close-up, ROBO Pro is designed to utilize icons that represent the different actions that the robot must perform, and students arrange these icons in a flowchart-style manner to create the programs for each robotic model. Now, the nice thing about using graphic programming software such as ROBO Pro for programming is that it allows students who may not have any prior experience with programming of any sort to quickly become comfortable doing so. And at the same time, it also helps to familiarize them with the core concepts that will be found in all types of programming. So that being said, we'll go back to the main page. Now, as you see right under the unit title, which is of course programming, the first thing that you will encounter in each unit is a section entitled The Purpose of the Project. Now, this is the section that seeks to clearly spell out to students the answer to that eternal question, so why are we doing this? See, too often in the past, students might encounter subject matter that didn't seem to have any relevance to them. I know for myself, going back to high school, it would have been trigonometry. Well, anyway, in this case, students are told why this material is necessary, where it fits into the larger scheme of things, and what we're going to hope to develop here. Next, right after that, you will see the concepts to be addressed in this unit. And these are essentially the big ideas that students should take from the project that will be essential for them to understand and utilize, not just today, but also to draw upon as they move forward in STEM fields of study and, of course, we would hope STEM-related careers. Now, following that, we get into the outline. And in this section, we drill down more specifically to what will be addressed in this unit. Now, again, as this particular section is focused on programming, you're going to see that we'll touch upon areas such as the methods for writing programs, which includes flowcharts, word problems, and so on. Program characteristics, for example, open or closed loop, branching, digital, analog, subprograms, and so on. After this, we come to the section where each of the specific standards to be met by this particular project unit are spelled out, which of course provides the educational justification for the project they're going to be doing. Now, because it's impossible to include all of the standards that have been created for individual states and school districts, what we've done is we've selected the most universally accepted standards that are currently used across the United States today. As such, we begin with the College and Career Readiness Math Standards, which are followed by the reading standards for literacy in history and social studies, as well as the writing standards for literacy in history, social studies, science, and technical subjects. After that, we have science standards, and we begin with the NSES content standards for K-12, followed by the standards for technological literacy, which are then followed by the ISTE Technology Foundation standards for students and the next generation science standards. After this, there is an assessment section, which includes links to both general course rubrics as well as the rubrics related to the specific unit in question. After that, we have what's called the essential question. And this can be thought of as the broad major idea to be explored in the unit. In this case, the essential question being put forth is, how can we make decisions electronically and remove the need for human intervention? After that is what we might think of as the centerpiece of each unit, which is the student scenario. Now, the student scenario for each unit gives the students an opportunity to explore the unit's essential question. And they do this in the form of a real-world problem that students are given to solve, which helps to provide a tangible example of why the subject matter being explored is both relevant and important to understand. Now, in this particular example, again, from the programming unit, students are asked to assume the role of a controller/programmer who happens to work at a programming company that specializes in designing elevators and writing the control packages for their clients. Now, once again, working in small groups, which is the way that all projects are approached in this curriculum, students are asked to work together to design an elevator that will have certain parameters and must be able to perform certain types of functions. An example of the specific type of function it might need to perform would be, in this case, what if the elevator was at rest on a middle floor and someone were to push a call button on a lower floor at the same time that another person pushed a call button on a higher floor? What students are going to have to do is have to create a protocol in the programming to address eventualities like this and which call button the elevator answers first. Now again, in this student scenario, all of the client's requirements are spelled out, and the students will be required to, again, design an elevator, create a program to address these specific requirements, build an actual elevator prototype using Fischertechnik, and eventually prepare a presentation for their fictional clients that includes an actual demonstration of the prototype and the program they've created in action. Following the student scenario, we get into the daily plan. The daily plan acts as a roadmap of sorts, clearly laying out the expectations the students are going to work through the project in the student scenario. Now, each day of the plan acts as a guideline to spell out specifically what the students will look at today and what they're going to need to accomplish. Now, you'll see that as different concepts are addressed, students are provided with helpful links which will give them more information. For example, here they'll have links showing them what will be required in the design brief that you've heard me mention. They will be asked to create and what kind of information they're going to need to track in their digital engineering notebook, and so on and so forth. Also, things like how to install the ROBO Pro programming software. And we're going to look at some of these links a little bit later. Anyway, again, each day of the plan contains a different task to be addressed, a different activity to perform, or a different question that needs to be answered. For example, now if you look closely at the bottom of the page on day 7, the page I have up on the screen right now, you'll see that there's a discussion topic. And the discussion topic on day 7 is, how does my dishwasher know when the dishes are clean? Well, of course, we all know a dishwasher doesn't judge or comprehend when dishes are cleaned, but instead it's been programmed a certain way to go through certain cycles for a specific period of time. And so here the teacher can lead a discussion where this idea can be explored further. Now, other things covered in this unit, for example, will include things like how data is taken from a sensor and recorded, or how files can be taken from the ROBO Pro format and put into an Excel format to be worked on, then put back into the ROBO Pro format, working on things like robotic positioning and so on. Now, I will point out this is one of the longer units in the curriculum. It continues for a period of about 35 days total. In any case, as students work through their daily plan and on their answer to the student scenario, once again, they're going to be required to perform research. They will be required to do trial and error experimentation. And again, they have to document the entire process. And this means, once again, maintaining a design notebook and a digital engineering journal. They will design and build a working prototype using Fischertechnik. If the model is automated or robotic, as it is in this case, students will also have to design the program that controls the model itself. Now, putting everything together, each student group will, at the end of each of these units, create and deliver a presentation of their prototype in action. The idea behind all of this is that each day builds on the one before it, and each activity is subsequently more complex, and along the way provides more of the information that students will need to draw on to successfully complete that project. What this does is it really helps to reinforce the concepts being addressed, and it ties everything together in a very organic and meaningful manner. Now, there are also various supplemental materials included at the end of each unit. Depending on the unit, this can include things like vocabulary words, carefully selected and vetted web-based resources, Word documents, PDF files, and PowerPoints. And once again, each unit of the curriculum for both the STEM Prep 2.0 and the STEM engineering sets follows the same structure as we've just looked at, including the standards, the rubrics, the daily plan, the resources, and so on. And as I mentioned before, there are also numerous links throughout the curriculum designed to provide more guidance on specific topics as they arise. Now, besides being linked this way throughout the curriculum, these sections have also all been collected in one place at the very end of the curriculum. Now, once again, using the STEM engineering curriculum as an example, there are links provided detailing information on such things as what is required in a design brief or in an engineering notebook. There's a section on schematic drawings, another on Ohm's law and power, one on how to program a robot to detect motion using the camera attachment, digital branching, working with flowcharts, open and closed loop programs, combinational logic, working with ROBO Pro, robotic positioning, working with sensors, working with data, using vision systems, subprograms, and so on. There's also a section where all of the rubrics for the curriculum are collected, and this means both the general course rubrics as well as the specific rubrics for each individual project theme unit. And finally, This is followed by a section containing the step-by-step assembly instructions that I mentioned before. And these are, of course, once again, what students can use to get ideas on how to address their various tasks that they'll have to do. Once again, the STEM prep curriculum will share the same structure, just with a focus, of course, on some different subject areas. Now, I'd like to share a few photos with you of one of the schools that's currently using the Fischertechnik STEM Prep 2.0 and STEM engineering sets. And this particular school is Westfield Technical Academy, located in Westfield, Massachusetts. Now, the program there is being conducted by Dave Roberts, who is the science teacher at Westfield. Now, what you see in these pictures that I put up here are the students as they address the first hands-on challenge that's presented in the curriculum for the STEM Prep 2.0 set, and that's the challenge of designing and building a prototype of a braking system, such as you might find on something like a racing bicycle. Students, again, work in small groups. As I mentioned before, with STEM Prep 2.0, we recommend one set per each group of 2 students. But with STEM engineering, because of the nature of the projects and the types of things that will need to be done, you could expand this group up to 3 or 4 students at a time. Now, as you will see from the photos, while the students are all working on the exact same project, there is no single one right way, no single solution for addressing the design challenge given in each unit's student scenario. Of course, some of the students will design and build prototypes that work very smoothly and efficiently, and others will create models that might need more refinement to really be practical. But the goal in any case is to see how well the students synthesize all the concepts they've learned, and how working in small teams, how well they can use their creativity and problem-solving skills to make something that will most effectively and efficiently answer the criteria given in the student scenario. Now, I'd also like to mention another benefit of the STEM Prep 2.0 and STEM engineering sets, albeit a somewhat unintentional one. Now, a large segment of the students at Westfield Technical Academy are what are classified as ESL students, which would be English as a second language. And these students happen to originally have come to the U.S. from Russia and the Ukraine. Now, in Massachusetts, teachers are required to take classes in ELL, which is English language learning, to help them to better meet the needs of such students. Now, Dave Roberts, who, as I mentioned before, is the teacher in charge of the Fischertechnik STEM programs at Westfield, has told me before that he's attended 3 different ELL training classes. And all 3 of these ELL training classes have specifically highlighted project-based learning as an important learning tool for ESL students. And the reason for this is because design is really considered sort of a universal language. And by working through the curriculum in this hands-on fashion, it helps to not only teach the students essential STEM-related concepts, but it also aids in their building their English language skills because it helps them to make the connection to actual processes and actions that they can understand. Again, what I've shared here is just a sample of some ways students can address this particular design challenge. As I stated before, each subsequent unit will require more sophisticated designs, and each will, of course, build on what has come before. So just to quickly summarize what we've covered, each Fischertechnik STEM Prep 2.0 or STEM engineering set contains everything you need, all of the parts, the software, all the assembly instructions, and complete day-by-day curriculum. And the curriculum included in each set is yours to use this year, next year, and of course, for many years after that. There are no additional fees, there are no subscription charges. Everything you need is included. And again, it's all reusable. Build a model, perform the experiments, take it apart, and you're ready to build another. Of course, if you ever did need any odd parts or replacement pieces, these can all be purchased individually in whatever quantity you may choose or need directly from our website. Again, the Fischertechnik STEM Prep 2.0 and STEM engineering sets are designed to make it easy for educators from any background to offer a hands-on, project-based learning experience to their students. And again, this is what experts agree is one of the most effective methods known for teaching STEM concepts. Once again, the STEM Prep 2.0 set, newly revised, now include Bluetooth robotics, comes with over 2,200 parts and components, Comes with day-by-day project-based curriculum PDFs for both students and teachers, with over 75 academic hours of material, as well as step-by-step assembly instructions from 9 popular Fischertechnik education sets for building 118 different models. And the pricing on this set starts at just $8.99 per set, with classroom pricing available upon request. The STEM engineering set shown here includes 890 parts components, including programming software, the full color touchscreen TXT controller, sensors, motors, and so much more, as well as student and teacher curriculum PDFs featuring over 150 academic hours of material and full color step-by-step assembly manuals from the 3 most popular Fischertechnik robotic sets. The pricing on the STEM engineering set starts at just $9.39 per set, and again, please contact us directly for classroom pricing and quotes. So on that note, if you have any questions, I would ask that you use your Zoom webinar tool. That's the easiest way to address those. Another way, if you, for whatever reason, didn't want to address them during the presentation, you can also email me. My email address, my direct email address is Lance Z, that's L-A-N-C-E-Z, and that's Z like zebra, at Studica, S-T-U-D-I-C-A.com. So you either, if you'd like to type anything in the chat window, or if you want to email me, either way will work. I won't keep people too long, so I will do the old auction. Yes.
Lance, I have one question. Is the STEM Prep 2.0 appropriate for middle school?
Does it work for middle school? Yes, actually the STEM Prep 2.0 is designed, it can be used in middle school. I would probably say anywhere from, like, you could go 5th, 6th, 7th grade would be fine. It could also be used by high school because it's, essentially you're covering areas that are going to be useful to both.
Okay.
Anyone else? Well, what I'm not going to do is I'm not going to keep you too long. On this note, I'm going to thank you all for taking the time to attend our presentation today. Again, if you'd like to know more about either the Fischertechnik STEM Prep 2.0 or the STEM engineering set, if you'd like to request a quote, or if you'd like to speak to a dedicated educational representative, you can call us to the numbers that you see on your screen now. In the U.S., our toll-free number is 888-561-7521. If you happen to be watching in Canada, you can call us at 800-561-7520. You can also find more information on both of these sets, as well as all the other Fischertechnik education solutions, right on the Studica website. And as you see, the address for that page is www.studica.com/Fischertechnik-education. Or you can email us. For quotes and pricing, you can please email info@studica.com, or again, if you'd like, you can email me directly with any questions, either at LanceZ, L-A-N-C-E-Z, @studica.com, or if you want to do my whole name, you can go lance.zurek, Z-U-R-E-K, @studica.com. Once again, I'd like to thank you all very much for attending, and I hope you have a great afternoon. Take care.